Hello, Flat Earth researchers, debaters, and debunkers. The physics and mechanics of flying appears to be demonstrable proof that we navigate and fly on or above a level and most likely stationary Earth. There doesn't seem to be anything that would indicate flying is done around a spherical Earth. Now, even when you ask pilots how they can prove this, all we have is an explanation that goes against what we would usually determine as level. And the way I see it, what is also determined as level from a mechanical and scientific physical standpoint of the level indicated in the flight level indicator that we can see here, which is what a pilot would see in the cockpit with an artificial horizon. And these, of course, have gyroscopes inside them, as you can see here on this cutaway diagram on the right. It's a very, very simple piece of equipment that basically relies on the physics of gyroscopes in order to maintain an indication of level. So the pilot always has a reference for level and then can determine what the attitude of the aircraft is, whether it's pitched up or down from level. Now, the way that gyroscopes maintain their axis of spin in whatever direction they are spun up is exactly why they are used to indicate level inside these flight level indicators. Now, there are arguments about precession of gyroscopes and things like that, but this could be a natural phenomenon that occurs. Either way, that doesn't matter or make any difference to what the gyroscope's job is and how it actually works to continually indicate where level is. And really, that doesn't seem to change. So let's go through a couple of scenarios to illustrate that. Remembering that this gyro in the flight level indicator is placed horizontally, and this is always the way that it will be spun up. So here we have the aircraft that is flying level on this red line. But let's change that a bit and keep this scenario in free space. There's no Earth to look at the moment. We're just going to look at what would determine the aircraft's level at any given point. So now we've just changed the orientation of the aircraft according to our point of view. For the aircraft in free space, then let's say that this is its designated level. And basically the flight level indicator and the gyroscope will be on this horizontal line that's not horizontal for us, but horizontal for the aircraft. It is the aircraft's level. So if the aircraft was at this attitude in free space, then the gyro would be spun up on this horizontal axis in relation to the aircraft itself without any relationship to the outside environment. And of course, the flight level indicator would read level. So from that point on, any change in pitch or attitude of the aircraft would change the reading on the flight level indicator as the gyro maintains its fixed plane of axis in space. Now, at the back of any globe Earth defender's mind are a few arguments relating to the physics of gyros, but they are contradictory. So first of all, we have this argument of precession, which gyros appear to exhibit. But I've seen examples of both. The idea is that gyroscopes do maintain a fixed axis of rotation in space at whatever direction they were spun up in. It could be vertical, it could be horizontal, or somewhere in between. And you spin up the gyro, and once it's spinning, it will maintain that fixed axis. Now, I've seen an example of a gyroscope left on a tabletop for 24 hours and nothing happened. There was no precession. But I've also seen videos in which someone spins up a gyroscope on an angle, and there is this precession which is assumed to be the rotation of the Earth, and the fact that the gyroscope is maintaining a fixed axis of rotation or spin in space, but because the Earth is rotating, then that axis appears to change to us watching it. But even so, what we have here is another claim that when an aircraft is flying above the surface of the Earth, it is following the curvature of the Earth because the axis of the gyro is this down direction perpendicular to the horizontal in this case because it's a flight level indicator. There are actually gyroscopes in other instruments that are of a vertical axis, and they of course relate to other aspects of the aircraft, especially in helicopters. But the argument often heard from globe Earth defenders and even pilots is that this direction of down for the gyroscope is determined by gravity, and that the aircraft follows this curve around the spherical Earth but maintains this indication of level on the flight level indicator because the downward direction of the gyroscope is always towards the center of the spherical Earth. But that's a direct contradiction with the real physics of the axis of spin remaining fixed in space. You see, you can't have this argument that the gyroscope remains fixed, regardless of whether there is any precession, which could be just a natural occurrence of a spinning gyro, not necessarily any assumed rotation of the Earth. Despite that, you have this contradictory argument that the gravity of the spherical Earth constantly pulls the gyro down. So that means that the gyro doesn't maintain a fixed axis of spin in space. So that explanation goes against the real physics and the real reason that gyroscopes are used in aircraft to determine level in the first place, regardless of any assumptions or descriptions or explanations of what's happening if and when a gyroscope precesses. Yeah? So it would be great to get some clarification from pilots collectively on what they can agree on or disagree with. Do you agree with this idea that a gyro does maintain a fixed axis of spin in space and therefore sometimes appears to precess? Or do you agree that the gravity of the spherical Earth in fact changes that axis of spin constantly, making it change from its original level? Which one is it? It can't be both. This is something that needs clarification and never comes because you just get a back and forth between these two arguments, and you end up with at least this admission that there is no way to determine that the direction of down has changed in any way from the departure to the destination. And of course you can do the mathematics to work out what the change in angle should be, and even if you travel 1,000 miles, there should be a huge difference in the direction of down. And if you've done what we've done here with this example, if you've ascertained your fixed level to begin with from the departure point, that will always be your reference point for the aircraft's level. So in this case, if we were on the side of the globe, we were coming down towards the equator somewhere, then this would be our fixed level from that departure point. And from then on, wherever the aircraft went, it would use that level as a reference, would it not? Given the physics of the gyroscope itself. I've done this experiment myself, traveling between Phuket, just above the equator, to the UK, stopping off in Dubai. We can have a look at that experiment now, and it just demonstrates that you I put the phone at whatever level you set the phone at, and then reset the level to be that orientation. It will then assume that whatever incline or decline you put it on is the phone's level. And so from then on, any change in level, even bringing it to natural level, will show a difference in the original level. So with that premise, the same premise that we have here, using the physics of gyroscopes, of course in a phone they're slightly different, but it works on the same principle. Again, you have the argument that down is only towards the center of a spherical Earth. That's not true, because you can set spirit level in a phone to be whatever level you want it to be to start with, and from then on any other change will register. And so no, level is not determined by gravity, it is determined by wherever you begin spinning up the gyro and determining the level from there on. Put it on the flat table. It believes that there's the bubble over there, and the roll is 20 and the pitch is 14 degrees. So the app now believes that the table is not flat because of being calibrated on the slope. You can see here that the bubble is way off on both of these, even though it is on the flat table. But when we put it back on the slope, it goes back to reading level on both of these. Okay, so this shows how the app can be programmed to determine what its original level is, and therefore read any changes in that level. So let's see how it is in Dubai. Right, I'm at Dubai airport now. We're at the just arrived at Heathrow and put this baby on the floor. It's still level. Okay, here's the fact. So that was a practical, real-life experiment attempting to measure any difference in the orientation of level assumed to be perpendicular to down towards the center of a spherical Earth. And if we illustrate it on this model here, we can see that we should have seen a vast difference in that direction of down, or the orientation of level. On the left here we have a point representing Phuket, which is at about 7 degrees latitude on the globe Earth, and then London is at about 51 degrees latitude. So we should have seen a difference of 43.7 degrees in the orientation of level between those 2 points. But contrary to the globe Earth model, the results we got from this experiment show us that we are flying above a level Earth, because we have the level of Phuket at latitude 7.8 established by the phone, and would have been established by the pilot when they spun up the gyros in the aircraft's instruments to establish level from the departure point. And then we have the aircraft going up to reach this level flight, and then eventually going down to London at latitude 51.5, 10,000 kilometers away from Phuket. But these two locations are on exactly the same horizontal level. And when we compare different parts of the flight, and the actual results that we got with the globe Earth model, we see even more contradictions. For example, we know that the aircraft would pitch up to gain altitude after leaving Phuket, and this would be indicated in the flight level indicator. The artificial horizon would drop because the aircraft is pitching up, and that of course is based on the level that was established in Phuket. No problem there. And then the pilot would level out the aircraft and maintain straight and level flight once they'd gained a cruising height. And of course there would be some pitching up and down of the aircraft's nose, but basically the flight path is straight and level, and this level is a parallel line to the level that was established in Phuket. Nothing would have changed because this is all about the aircraft's level. It has nothing to do with whatever ground lies beneath the aircraft, unless the aircraft pitches up or down from the originally established level. So then the aircraft heads towards its destination in London. Now, in reality, the aircraft doesn't pitch down like this all the way to London, and that's an important point to keep in mind when we compare this flight path with a globe flight path, because in reality what the aircraft usually does is maintains a level attitude as it descends. The pilot reduces power and does other things to bring the aircraft down, but predominantly maintaining level. And again, that level is an internal reference for the aircraft that was established in Phuket. In our experiment and our measurements, nothing changed in the orientation of level between those two locations. But if we compare that with the globe Earth model and the kind of curved flight path that we can see represented by this green line, we see quite a few discrepancies. First of all, of course, in this illustration, Phuket is not the same level. It's on this side of the globe. Now, as we saw earlier, we could say that it doesn't matter where you are on the globe. If you establish level to start with, whatever your orientation in this orthographic view, then that is level for the aircraft. So that's fine. We can say that even though we are at this orientation on the globe, that is our level based on down towards the center of an imaginary spherical Earth and a perpendicular horizontal level. So then we go along this flight path. We're about halfway, and this would be our level that's parallel to the initial level on a level Earth, but this of course is already quite a few degrees difference in the direction of down and the perpendicular horizontal compared to the departure point. And then as we go towards the destination 10,000 kilometers away and about 43 degrees difference from the departure point, we now have the plane pitching down relative to the level that was established over here in Phuket. So with the way we did the experiment and the way that gyros work, we should be able to measure a distinct difference in the horizontal orientation based on this assumption that that horizontal level is perpendicular to down towards the center of a spherical Earth. There should be a way to measure it that way, and those are the results we should have got by the way we measured it with the phone. So as far as I'm concerned, the Earth is demonstrably, measurably a level plane. And anyone who wants to claim otherwise must come forward with a practical demonstration, because no amount of explanations will do. And we've seen already that the explanations that come contradict each other and do not fit with reality. So again, that question, get it straight in your mind. Which do you believe? Do you believe the real physics of gyros and that they remain on a fixed axis of rotation once they have been spun up? Or do you believe that gyros magically follow some imaginary curvature? If you do believe that, then you're going against real physics and you're going against the measurements that we ascertain from real life. So don't come here defending your belief with models or explanations. They simply will not do against the demonstrable reality that we fly and navigate above a level Earth. It doesn't matter whether you talk about maps and models. Just because you have different latitudes and that you can place them on a spherical map, it means nothing compared to the reality of the situation where level does not change from one point to another, no matter how far away they are from each other. You'll feel free to try and prove me wrong, but do it with a practical demonstration in real life. Thank you very much.
Click subscribe and the bell icon if you'd like to receive notifications of new videos from Phuket Word.